How can we link between the Riemann sum form and the definite integral? So, or vice versa. We will do it in the next exercise. So in this case, we should be able to rewrite this definite integral into the form of into the Riemann form. We follow the first okay, the steps that we have done before. So first we define what is delta x. That is equal to b minus a over n, and in this case it's a 3 minus 0 divided by n equal to 3 over n. Next is we define the xi. So xi equal to a plus delta x times I, then it's equal to a, in this case is 0, plus delta x 3 over n times I equal to 3I over n. And next is we define the area of each rectangles under the curve, which is let's say ai, then equal to delta x times xi, or sorry, f xi, but I'm more familiar with f xi, delta x. Okay, so then this is become what is fxi? Fxi is epsilon 3I over n, okay, times delta x, which is 3 over n, and the Riemann form for this one. So Rn then equal to sum of the rectangle from n equal to 1 until n of fxi delta x epsilon 3I over n, 3 over n, and the definite, so the, and then we also need to define it is close to infinity, right? So integral then from 0 to 3 epsilon x dx equal to limit n approaching infinity for Rn. Rn is sigma n equal to 1 until n, epsilon 3I over n, 3 over n. Okay, in the second exercise, okay, here we'll do the opposite. So how can we find the integral expression for a given Riemann sum? Okay, this is a little bit, you need to do it a little bit with some intuition, okay, because we don't have a set procedure like the way we do it for finding the Riemann sum expression. But what we can do here is that we need to recall the form of the equation. So so the Rn, the form is actually a sigma n equal to 1 until n f xi delta x. So in this case we can we can see from the form, most likely that this form will be delta x, and the other will be the fxi, right? So we know that delta x then equal to 5 over n. This is equal to b minus a over n. So we know that b minus a equal to 5. And then the second one of that is a little bit hard, so we need to guess. So the guessing could be that so fxi, so I'll just do it here. Fxi in this case maybe can be, okay, might be, okay, this is just guessing, a plus this is a function of a plus delta x times I. So okay, so by looking into that form, okay, so I can safely make an assumption that most likely fx then will be equal to okay, from the form above there, most likely equal to square root of x. Okay, and in this case, if this is a square root of x, I would know that yeah, it's a little bit hard, and in this case probably a then equal to 4. So since b minus a equal to 5, so I know that actually b equal to 9. Then this expression can probably be, this is just an expressed as, this is from 4, remember, a, because we know that a equal to 4 and b 9, and then fx is square root of is a square root of x delta x. Okay. To make sure if our answer is correct, we can always check back according to the procedure we use in the previous exercise. So here, let's say now we want to revert back this integral, definite integral, into the Riemann sum form. So we'll have a delta x then equal to b minus a over n. So you have 5 over n, and you have an xi then equal to a plus delta x times I. This one equal to, then now you have a equal to 4 plus 5i over n. Then you have an fxi equal to square root of 4 plus 5 over n I. So we can have an ai equal to fxi delta x, that's equal to square root of 4 plus 5 over n I, 5 over n. So the Riemann sum for this then equal to, this is n equal to 1 to n, square root of 4 plus 5 over n I 5 over n. So the Riemann sum then is a limit of n approaching infinity for sigma I equal to 1 until n square root of 4 plus 5 over ni times 5 over n. So this is how we can prove back if our answer from the intuitive derivation. Okay.